Welcome to CW 2.3. Today we're covering the rational zero theorem. So I'll highlight this for you. So the theorem is right here. You don't necessarily need to write down all of this. I'm just showing you the formal theorem because I'm going to explain how it actually works. That's the most important part. Now it says if f of x equals, this is how you generically write a polynomial. That says a sub n, x to the n, a sub n minus 1, x to the n minus 1, and it goes all the way down to your constant term. So that right there is your constant. So this is saying if you have some function and it has a rational zero p over q, p is a factor of a0. So I'll highlight that. And then it says q is a factor of an, which is this first part. So it probably sounds pretty abstract right now. So let's kind of put that into context. What we're saying is the rational zero is p over q, that thing. So this represents like some fraction. So the question says list all possible rational zeros of this function. So start by writing p over q. Now the way the theorem works is you're going to put plus or minus, you can put a big bracket, and a division bar. What we're trying to do is figure out every possible rational zeros, or every possible rational zero. So you're going to circle this last number. That's going to be your p values, and this first number is going to be your q values. So that number is 4. So think of all the possible factors of 4. That would be 1, 2, and 4. Right here you have -1, but just think about 1. And the factors of 1, well, that's simply 1. This right here, that's all your possible rational zeros. So if you're to simplify it, you could say plus or minus 1, 2, and 4. Now, for a quiz or test, you could leave it like that. MyMathLab will just make you write it out. And it is important to understand that this represents that there are in fact 6 numbers. So I do like that it reinforces that idea. But again, this would be okay for class. And that'll be the MyMathLab answer. So now let's put that into context. Like, what are we really doing? So imagine this problem right here. 2x squared plus 7x plus 3 equals 0. We would factor it. We get 2x and x, 1 and 3, plus and plus. And we get x is equal to -1/2 and -3. So notice how these are the zeros, and I'm just going to make it into a fraction, just so you can kind of see it. Notice how the numerators, 1 and 3, are related to this. That's your p. That's all the possible factors of 3. And your denominators, 2 and 1, are coming from right there. That's your q. So this theorem is just a fancy way of saying if something is factorable, the zeros have to be composed of factors of this last number over the first number. And that's all we're really doing. So let's try another one. A little bit longer example here. I'll draw a line for you. Again, we're going to write p over q. And you put plus or minus because the theorem, when you find these factors here, it's possible that any of them could be positive or negative. So to handle that issue, we just put a plus or minus at the front. I'll put a big bracket, fraction bar, and recall this 2 is your p, this 15 is your q. So the numerator, think of the factors of p, or the 2, that would be 1 and 2. And your denominator, let's write out the factors of 15. 1, 3, 5, and 15. So for class, this is again how you write it for a quiz. You just condense it. You would say, well, plus or minus 1 is an answer. I'm going like 1 over 1. You could also say 1 over 3, 1 over 5, or 1 over 15. So I'm just going 1 over 1, 1 over 3, 1 over 5, 1 over 15. I need more room, so I'll just move this over. And I'll do the same thing for the 2. 2, 2 over 3, 2 over 5, and 2 over 15. And that's it. Now remember, for my math lab, it might ask you to write these out. And if that does that, there's no problem. Just make sure you type it out. But for a quiz, you could leave it like that. And this, again, represents possible rational zeros. Again, what's possible? Now, the reason we have this theorem is because now we have a tool to attack a question like this. It says, find the zeros of this equation. Because previous to this, you could only really solve things that had x squared in it. So now we're going to talk about, well, how do you do it if the degree goes beyond 2? You start with your p over q, plus or minus. At this point, you should feel a little bit better about it. So the factors of 6, that would be 1, 2, 3, and 6. And the factors of 1, that's only 1. So now we have plus or minus 1, 2, 3, and 6. Now this is what some people are going to have you do, or some teachers. They would say, now we're going to do synthetic division. We're going to write down those coefficients, 1, 2, -5, -6. And we're trying to figure out which of these, there are 8 possibilities. Which of these, when I put it in right here, is going to make the remainder 0? Because that's what we're trying to do. We're trying to figure out what's a 0. So we need to make this remainder 0. So you might be thinking, that would take me forever, because there are 8 possibilities, and every time I try one, I'm just going to basically do a guess. And there is a method that I teach that should help you out a little bit. There are a couple of tips I'm going to give you. You want to start small. That will help. And then the second thing we're going to think of is recall the remainder theorem. The remainder theorem says if f of a equals 0, then a is a 0, because the remainder would be 0. So we're going to use that fact. So imagine we start with 1. We're going to plug in 1 to this equation. So I'll do that right here. 1 plus 2 minus 5 minus 6. All we got to think is, does this thing equal 0? Clearly it does not, so I know that 1 doesn't work. Now try -1. So that would be -1 plus 2 plus 5 minus 6. Does that equal 0? It does. Which means that -1 is the one we want. We're going to put that right here. Let's do synthetic. Drop the 1, multiply, add, multiply, add, and look at that. We do get 0, which had to happen because we checked it right here. We knew that -1 would work because of the remainder theorem. Now we're going to contextualize the answer. What we just found is that x plus 1 is a factor, and that's because, again, -1 is a 0. Now that would mean x plus 1 times this thing, x squared plus x minus 6, has to equal 0, and now I can solve it. Let's factor that second piece, and we have our answers. X equals -1, -3, and 2. This one we're going to do together because I want to talk about some techniques that we can apply that involve some logic. We have P over Q, and let's do that really quick. Plus or minus 1, 3 over 1, which basically means we have plus or minus 1 and 3. Now, as we're doing this, again, we want to be smart about it. Like, we don't want to spend too much time stuck on the synthetic, right? Because we want to get through this part as fast as possible. So we want to be smart about the numbers we pick. So I said to start small. Now if you look at this equation, this is pretty interesting. Really look at this part right here. X cubed plus 7x squared plus 11x minus 3. We're trying to make it equal 0. So again, I'll write it out for you right here. We want this to happen, but notice how this whole front term, these are all positive. That actually tells you something. That's super important. That would mean that positive 1 and positive 3, so we have 1, negative 1, 3, negative 3, we can actually eliminate these. These we won't even bother trying because there's no way you can plug a positive number here and then get a 3 to cancel out that 3 to get a 0. So we'll get rid of those. Which means at this point, look, we only have two options, negative 1, negative 3. So we can just plug it in. You can start with the negative 1, so let's plug it in, negative 1. So plug in negative 1 for x, you get negative 1 plus 7 minus 11 minus 3. Does that equal 0? It does not, which means that one, negative 3 is the one we want. So no sense in checking, it has to work. Negative 3, 1, let's multiply, negative 3, 4, negative 12, negative 1, 3. And look, we do get our 0. And again, make sure you draw a happy face. You're going to feel good when you get 0, so make sure you really reinforce that for yourself. Now what we're going to do is contextualize. So let's take this answer here. That would mean x plus 3 was the factor. We're multiplying it by x squared plus 4x minus 1, and that should equal 0. So we did all that work so we could factor it. And now we're golden. We have this one. If we look at this, we should recognize that is not factorable. That's okay. So you could complete the square or quadratic formula. I'm going to recommend you do the quadratic formula because at the precalc level, this should be pretty comfortable. Opposite b plus or minus the root of b squared minus 4 times ac all over 2a. So x equals negative 4 plus or minus. This part right here is the root of 20. So that would be 2 root 5 over 2. Now we reduce it. That's just negative 2 plus or minus root 5. And then we take that solution as well. Don't forget that one. Negative 3. And those are the final answers. If you need extra practice, please do this one. And I put the answers right here.